Greetings all. Let me show you the plans for the day real fast. I'm going to have my sub, whoever that lucky person may be, give you a skill check. Do that on your own. Looks like there's 6 problems on there. Just reviewing what we did last time from section 7-1. And then what I need to do today is I need to show you how to undo the chain rule. And then for your assignment, most of it will be a worksheet, but I haven't done this yet, but I will. I'll make a short Math Excel assignment. That way you have 4 or 5 problems just to make sure you know what you're doing before you move on with the worksheet. So you should have a copy of your class notes also. The skill check's on top of that. Class notes are right below that. These right here are not on your notes, but what I wanted to do with you real fast is just review the chain rule with you. So here's f of x equal to x plus 3 to the 5th. I know this derivative is going to be 5 times 2x plus 3 to the 4th. Remember, we're doing the derivative right now, times the derivative of whatever's inside there. So I know this derivative looks like 10 times 2x plus 3 to the 4th. So here's a true statement. The antiderivative of 10 times 2x plus 3 to the 4th dx, that's what we did last time, is 2x plus 3 to the 5th. Plus c, of course. So, of course, your goal today is going to be this. I will be giving you something like this. You got to go to that. Just another one real quick. The derivative of this, I'm going to think that as to the 1/2. So 1/2 x squared minus 4 to the negative 1/2 times 2x. If I simplify this, I got f prime of x equal x times that, so it looks like that's going to be on the bottom. So here's a true statement. The antiderivative of x over the square root of x squared minus 4 dx is the square root of x squared minus 4 plus c. Looks kind of hard. I'm going to show you how we'll rewrite these and try to make them simpler. And then just one more last one real fast. This one's a little bit easier. Maybe you'll catch a pattern. This derivative looks like 32, 3x plus 7 to the 7th times 3. So this derivative looks like 96, 3x plus 7 to the 7th. That means this statement is true. The antiderivative of 96, 3x plus 7 to the 7th dx is 4 times 3x plus 7 to the 8th plus c. You probably got the power part figured out. Add 1 just like we did last time. What I got to do though is I got to show you a little trick to help us get those constants out front that makes everything work right at the end. So here's where I'm going to go. What I need to do today is get you familiar with which of these look easier to find the antiderivative of. A quantity to a power or a simple u to a power. Something quantity to a power or a simple u to the power. Well, of course I'm hoping they say, holy cow, Mr. Harris, these look a lot easier to find the antiderivative of. So here's my goal to the day. I'm going to try to rewrite everything in terms of u. In calculus, it's called u substitution. And it's a method to make things easier for us. So here's what I'm going to do. I'm going to dive right in and show you what I got. I'll confuse you on the early ones. You'll think, well, wait, I got a shortcut for that. But that doesn't always work. The rule today is very similar to what we did last time. Just like when we found the derivative of the chain rule, it was just like the power rule. We just multiplied by the derivative of the parentheses. I've got to offset that derivative of the parentheses. And I'll show you what I mean. Here's the first one on your sheet. The antiderivative of x plus 1 to the 7th dx. Here's going to be our steps. Take whatever your quantity is and let that be u. So here's what I got. I'm going to let u equal the quantity x plus 1. Not to the 7th power, just whatever's in the parentheses. Now, find the derivative of u. The derivative of u is 1 dx. Now here comes the u substitution part. And like I said, I'm going to confuse you on this early one. It'll get easier. When I rewrite this now, I've got the antiderivative of x plus 1 is u to the 7th. And then 1 dx, there's a 1 right here, dx, another name for that is du. Now go find the antiderivative just like we did last class. I'm going to add 1 to the power. I'm going to multiply by the reciprocal and put plus c. Now I'm going to sub in what u is. So here's my final answer. I've got 1/8 u, which is x plus 1 to the 8th, plus c. So there's my answer. Guys, these are so easy to check real fast. You don't have to do this on your assignment, but to find this derivative, I'm going to bring down this 8. Well, 8 times 1/8 is 1. X plus 1 to the 7th times 1. Notice that gets me back to what I started with. So those will be my steps. I will just try to pick the pace up for you. So here goes my next one. The antiderivative of 2x, x squared plus 1 cubed. I'm going to let u equal x squared plus 1. That's the quantity, not to the third. I'll take care of that later. Then that means the derivative of u is, the derivative of u right here, 2x dx. Here's what I hope to see. I hope to see a 2x and a dx. And since this is just my first example, there's my 2x dx. So now when I rewrite this, here's what we got. I've got the antiderivative of, this part right here is u, so u to the third, 2x dx is du, so 2x dx becomes du. It's not always that simple. Now when I do my antiderivative, this becomes 1/4 u to the 4th plus c. So my solution becomes 1/4 u, which happens to be x squared plus 1 to the 4th plus c. So here's my answer. But Mr. Harris, where did this 2x go? Let me show you where that 2x would show up. If I gave you this equation right here, this function, and asked you to find the derivative of it, here's what I'm hoping you would do. You'd bring down that 4, leave that 1/4 as it is, x squared plus 1 to the 3rd times 2x. Notice the 2x shows back up when I do the derivative. So it's gone, but it will show back up. So I'm going to keep it up. I'm going to keep the pace up a little bit. Another simple one, and then I'm going to switch it up just a little bit. So on this one, I'm going to let u equal 3x minus 1. That means the derivative of u is 3 dx. I hope to see a 3 and a dx. And I do, so this is another easy one. When I rewrite this then, I've got the antiderivative of, this part is my u, so I got u to the 4th. The 3 dx becomes du. Notice that at this point I have no x's, everything's u. So this really becomes 1/5 u to the 5th plus c. Now sub this back in. Answer 1/5 3x minus 1 to the 5th plus c. So there's my answer. Hey, now don't think that it's just that added by 1 and multiplied by the reciprocal. Because on my next example, this number we got to start tweaking a little bit. So here goes, watch this one. I've got x squared times the square root of x cubed minus 2. So I'm going to let u equal x cubed minus 2. That makes the derivative 3x squared dx. Here's what I'm hoping to see. Keep up with this part because it's the first one. I'm hoping to see a 3x squared, but I don't this time. All I see is an x squared dx. Here's how I need to do that. Since I need to see a 3x squared, I'm going to put a 3 with that sucker. And you're thinking, well, wait, you just can't do that out of the blue. But what I'm going to do, since I put a 3 inside the antiderivative, I need to offset it with a 1/3. Because to be truthful, I only multiply by 1. but I need that 3 there, and I will show you why. Now, when I start doing this, I'm going to have 1/3 times the antiderivative of, hang with me, this becomes u to the 1/2. The 3x squared dx becomes du. I will show you the importance of that 1/3 here in a heartbeat. So now, let me go get this antiderivative then. I'm going to add 1. I'm going to multiply by the reciprocal, and I still have that 1/3 out here. And I still got my plus c. So now when I simplify this thing, looks like 1/3 times 2/3, looks like I've got 2/9 times x cubed minus 2 to the 3/2 plus c. Now let me show you what would happen real fast. The purpose of this 1/3 that I used there, and there was to get this 2/9. Let me check this one, because I won't check them all, but if I was to do this derivative, I'd have 3/2 times 2/9 times x cubed minus 2 to the 1/2 times 3x squared. I'm hoping when I simplify this, guys, I get all the way back to what I needed to start with. So check all this out. Oh, 3, looks like my 2's can cancel out. I got a 3 times 3 is 9. Divided by 9, all of that canceled out, leaving me an x squared and an x cubed minus 2 to the 1/2. So I needed this to help me get that. Okay? That's a little weird, but it's kind of undoing the chain rule. So while I got you a little confused, I'm going to keep on keeping on and see what you think. I'm going to let u equal 1 minus 2x squared. That means du is going to be negative 4x dx. I'm going to look and hope to see a negative 4x dx. I do. So not much extra. I don't have to work with the fancy number on this one, but I will over here. So when I begin rewriting this, this part to the third becomes u to the negative third. The negative 4x dx becomes du. Notice I didn't have to introduce a constant out here this time. Now let me go get my antiderivative. Add 1, multiply by the reciprocal. So it looks like I've got negative 1/2 u to the negative second, so let me just put that down here as 1 minus 2x squared plus c. So there's my answer on that one. So hopefully I'm hanging with you. Remember, guys, on this, you can always stop it, fast forward it because you don't like the way I look. Oh, wait, you can't see the way I look. Pause it so you can re-see things, whatever you need. Here comes one where I got to tweak it. My u in this case is going to be 3 minus 4x squared. The derivative of u is going to be negative 8x dx. So I need to see a negative 8x dx, and I don't. So what I'm going to do is I need to put a negative 8 right there. Now I see a negative 8x dx. To offset that, I'm going to put a negative 1/8 on the outside, because negative 1/8 times negative 8 is 1. Now when I go to rewrite this, all of this becomes this. This right here becomes the antiderivative of u to the fifth. Negative 8x dx becomes du. And I've got that negative 1/8 out front. Remember, I need that so at the very end I get back to what's in white right here. So let me add 1, multiply by the reciprocal, and I still have negative 1/8 out there. Now when I go get my answer, negative 1 over 48, u, which happens to be 3 minus 4x squared to the 6th, plus c, and then boom, I got my answer. If I took a second to check it, guys, I'd have negative 1/48 times 6 times negative 8x, and 3 minus 4x squared to the fifth. But 6 times negative 8 is negative 48, which would cancel out of that, leaving me this x right there that I need. That's why I need that number. Here comes my next example. Hopefully you got the hang of it. I'm just going to kind of keep clicking them on. My u is going to be, you guessed it, x cubed plus 1. That makes my du 3x squared dx. I need to see a 3x squared dx, and I don't. I see a 9x squared. I'm going to show you two ways to handle this. I need to turn a 9 into a 3. So you could say divide by 3, which would be the same thing as multiply by 1/3. Here's how I handle it. I turn a 9 into a 1, so I'm going to multiply by 1/9. I need a 3 though, so I'm going to multiply by 3/9, because I'm going to erase this in a second. 3/9 times 9 gives me that 3. I've had some people that really struggle to see what to do, so here's another option. You are always welcome. If there's a constant right here in your way, you can move that out front. You can slide it around. Now you need to see a 3x squared. Put a 3 there. That means you put a 1/3 out here. So here's what I finally got. 9 times 1/3 is a 3. Antiderivative of. This part becomes u to the 1/2. The 3x squared dx becomes du. And that's a typo, guys. That should not be underneath my radical sign. Add 1 to that, so I got 3/2, 2/3, and a 3. So my final answer, 2u, which happens to be x cubed plus 1 to the 3/2 plus c. I'm going to backtrack just a little bit, because normally, guys, every year there's a question right there like, whoa, Mr. Harris, how did you get all that again? So hang with me just a second. Let me get rid of some of this. U was x cubed plus 1. Du was 3x squared. 9 times something is 3. So here's my thinking. I can turn any number to 1 by multiplying by the reciprocal. So what did I do? I multiplied by 1/9. Now I turn that into a 1. I need a 3, so I'm going to use 3/9, which is 1/3. So I'm going to multiply by 1/3, which leaves me a 3 out here. After you do a couple, you'll decide what works easiest for you. But that's how I'll get that number. I'll hit it this same way over here. So not too many more examples. I added in a couple of more examples since I wasn't there to catch questions, but here goes. My u is going to be x squared plus 3x plus 7. That makes my du 2x plus 3 dx. So I need to see a 2x plus 3. I don't. So here's what I'm going to do. I can turn 4x plus 6 into 2x plus 3 by multiplying by 1/2. If I do that, then out here is a 2, because 2 times 1/2 is 1. So 2 is my important number to make sure everything comes out right. So now this becomes 2. Let me take care of this part first. All of that to the third, since it's on bottom, becomes the antiderivative of u to the -3rd. When I distribute here, I'm going to get 2x plus 3 dx, which is what I wanted to see, so I've got du. Now I'm off to the races. Add 1, so I got -2. Multiply by the reciprocal and get -1/2 times 2. If I simplify this, looks like I get -1 u to the -2nd, technically plus c, which I'd make sure I added in by the end. So my answer, -1 over u, which is x squared plus 3x plus 7 squared plus c. Mr. Harris, where did that 4x plus 6 goes? It would show back up if I asked you to do that derivative. Because we'd bring all that up times the derivative of the parentheses, 2x plus 3. So there it would show back up. So I've got a couple more. And really what I'll try to do on these next one, guys, get you better with these numbers right here. That's the key to this. Here's my next to the last one, or my last one on your sheet. If you understand what I'm doing right after this example, hit stop and then go on with yours. Otherwise, I did two more real fast just to show you. So here goes. I'm going to let u equal x squared minus 4. That means du is going to be 2x dx. So I need to see a 2x. Two ways to take care of that 5x. One way, you could move it out here, put the 2 here, and since you added that 2, offset it with a 1/2. So one way would be multiply by 5/2. That's one way. Another way to get, here's what I do, because I'm okay with numbers in my head. I need to turn that 5x into a 2, so I say 1/5 turns it into a 1. I need a 2, so I'm going to use a 2/5. 5's would cancel, leaving me a 2. Since I used a 2/5 there, that means I need a 5/2 out here. So whichever way you want to do it. I'm going to turn this into 1/5, doubled as 2/5, leaves me a 5/2 right there. Now when I rewrite this, I have 5/2. This part here, the denominator, becomes u to the negative 1/5. 2/5 times 5, which is 2x dx, becomes my du. This is a very important number. It makes things right when we do the derivative. Now to bring this home, I got 5/2 times. I'm going to add 1 to the negative 1/5 and get 4/5. Multiply by the reciprocal, which is 5/4. Ending answer, 25/8 times u, x squared minus 4 to the 4/5 plus c. If you wanted to check it super fast to make sure your constant's right, I'm going to go 25/8. I'd be multiplying by 4/5. And then I would also be multiplying by the derivative of the parentheses, which is a 2x. I'm hoping if I simplify this real fast, I'm going to get 5x. So 2 times 4 is 8. 25 over 5 is 5. So I know I'm right. So there's my answer. Like I said, guys, I put 2 more in here that I'm going to click through. If you're good, then start your worksheet or your Math Excel. If not, watch these 2 examples, watch me get the number, and we'll be good. So here it goes. My u is going to be 4x squared minus 11. That makes du 8x dx. I need to turn this 12 into an 8. So here's what I'm going to do in my head. I'm going to multiply by 1/12. That turns it into a 1. Now to turn it into an 8, I'm going to multiply by 8/12. I'm going to multiply this by 8/12, which means on the outside, I need a 12/8, which I'll reduce here in just a second. But I wanted you to see 8/12 times 12 is 8. That's what I needed. So 12/8. This part becomes u to the 1/3. And then the 8/12 times 12x becomes my 8 du. And then I'm off to the races. 12/8 really becomes 3/2. Add 1 to my power, so that becomes 4/3. This becomes 3/4. Ending answer, 3 times 3, so I've got 9/8. 4x squared minus 11 to the 4/3 plus c. Okay. Easy to check again. I always check my powers. 9/8 times 4/3 times 8x. I'm hoping to get a 12. 8's are out of there. 3 goes into 9. 3 times 4 is 12. Okay. And then here's my last one. Nothing any harder about this one, but My u again is going to be 3x squared plus 4. That makes my du 6x dx. So here goes. I need to turn an 11 into a 6. So I'm going to multiply by 1/11, which turns it into 1, and then I'm going to multiply that part by 6. So I'm really going to use 6/11. So I'm going to use a 6/11, which means I use an 11/6 out there. Because 11/6 times 6/11 is 1, my number of Facebook friends. So here goes 11/6, antiderivative of, this part becomes u to the negative 1/2. This part becomes du, because the 11's cancel off, and I got a 6x dx. Add 1, multiply by the reciprocal, 11/6 still, so it looks like I got 22/18. 22/18. U, which is 3x squared plus 4, to the 3/2 plus c, and then I'll call 22/18 what, 11/9? So it looks like I got 11/9, 3x squared plus 4, to the 3/2 plus c. Okay? And then what I always do is I check it to make sure it comes out right. But I haven't set this up yet, so I hope it turns out well. If not, you will have received an email. But on Math Excel, I'm going to find probably around 5 problems of these. That way you can check them right off the bat. So do those 5 problems if you will, and then you should have a worksheet. If you have any problems, I hope to be back Monday. So good luck with it, and have fun.